In this presentation, 4 professionals from different disciplines discuss their opinions on the issue of informal ULAB recycling and propose applicable interventions. This presentation was facilitated and curated by Nonye Okafor, a Master of Public Health student at NYU. To ensure all professionals were provided with sufficient amount of information and time to speak, discussions were conducted in a one-to-one setting. Prior to the discussion, I provided a 5-minute overview of what are used lead-acid batteries, otherwise known as ULABs, and the issue regarding informal ULAB recycling. This led us into a 15-minute discussion in which I asked, from their perspective, why do they believe it's a problem, and if they had any opinions regarding ULAB recycling. Finally, a 10 to 20-minute post-discussion occurred, in which I queried each professional on how they thought we could effectively address the issue, and if they had any possible interventions that could be applied. Most of the world's lead-acid batteries are used for automotive purposes, such as for cars, boats, motorcycles, lawnmowers, and even scooters. They may also be used for generators, lighting, and in heavy machinery such as forklifts. Depending on the size and purpose for the lead-acid battery, the longevity varies. Extreme heat and other environmental factors can significantly reduce the life of a lead-acid battery. In regards to cars, the average lifespan of a car battery is about 1,500 cycles, or 3 to 5 years before needing replacement. Batteries which are no longer viable for its purpose are used lead-acid batteries. In regards to informal used lead-acid battery recycling, due to these batteries' simple construction and components, mainly lead, acid, and plastic, they approach a global recycling rate of almost 99%, which is very impressive. As a result, many informal ULAB recyclers, typically in lower-income countries, collect these batteries, break them apart, melt and smelt the lead component, and resell it for profit. Although lead-acid batteries are a very important commodity in our global market, they can also pose several hazards and serious public health risks if not handled and recycled properly. Lead is a highly toxic heavy metal, which comprises about 65% of lead-acid batteries. Another 10 to 15% of the batteries are composed of sulfuric acid, which can cause skin burns and damage to the eyes. Broken batteries can leak sulfuric acid from the battery and contaminate soil and groundwater. In turn, animals may interact with these contaminated items on the ground or drink contaminated water. Toxins can bioaccumulate in animals, which directly impact those who eat animals. Melting and smelting the lead from the batteries can cause fumes and black smoke to be dispersed in the air, causing respiratory issues in those around. Lead dust carried home on the clothes and shoes of recyclers can contaminate families, especially those living within the same domestic residences, as well as the workers themselves. The issue with the informal ULAB recycling process is that it can not only be dirty, but at times improper, and it can cause both distal and proximal health effects to humans, animals, and the environment. This word map highlights the collective perspectives and opinions from the one-to-one discussions with the 3 professionals. As you can see, despite the very different disciplines for the 3 professionals, their opinions on the issue still created a unified word map. Words such as lead, hazard, alternatives, society, environmental justice, global, law, incentives, disincentives, accountability, pollution, monetary, humans, negative, and policy were used to express their perspectives on why used lead-acid battery recycling was an issue. The overall sentiment from this discussion was that lead-acid batteries in themselves were definitely an issue, but the informal recycling was a greater risk to the health of society, humans, and environment. Regardless of the epicenter of this issue, it was decided that it was everyone's issue to mitigate the impact of the used lead-acid battery recycling. After the discussion, I introduced the issue of the Agbogbloshie scrap metal site in Accra, Ghana. This site is the largest center for e-waste recycling and disposal. Workers manually disassemble parts and burn off the plastic encasements on computer wires and refrigerator coils to recover profitable metals. The work is often done by young adults using handmade tools and without PPE, leaving them susceptible to respiratory diseases and overexposure to lead. the issue of pollution and e-waste dumping at the site has become unmanageable. Those working there are simply trying to make the most of a bad situation. It's unfortunate that after anything of value has been stripped away, the bulk is then dumped untreated into unlined pits and waterways. An additional health hazard is the black smoke that continuously hovers over the site, resulting from piles of copper cables that are lit to burn off the plastic coatings. Air pollution from the burning affects workers as well as those living and working nearby. Currently, an ongoing project to address the issue of informal e-waste recycling and cleanup of the site has been underway since 2013 and expanded to multiple partner organizations such as Pure Earth, Blacksmith Institute, and Green Ad Ghana. Interventions have been applied, and the project team is open to other creative suggestions from the public. Interventions and approaches were given by each of the professionals. The approaches that were targeted directly towards mitigating the issue in the Agbogbloshie scrap metal site in Accra, Ghana, are highlighted in yellow. Professional 1, a third-year law student at Georgetown University Law Center, provided 3 approaches. The first one being increasing consumer awareness about the issue of used lead-acid batteries. The second one being shifting the blame to the manufacturer to promote accountability from the source of lead-acid batteries. And finally, manufacturers should provide oversight or a handoff guide for countries that are receiving their used batteries. 2 challenges in regards to executing these approaches are 1. Creating a way for consumers to weigh in on the process, and 2. Deciding where to post a handoff guide so that it is accessible to all countries, especially those most impacted. Professional 2, a software engineer at Google, provided 2 approaches and 1 challenge to this issue. Their first approach was education in schools about the negative impact of informal ULAB recycling, and their second approach was providing greater monetary incentives to recyclers if they follow protocol. A challenge in actioning this issue is acquiring funding for incentives. Professional 3, a senior consultant at Deloitte, proposed a mixture of primary prevention as well as indirect and direct approaches to addressing the issue. Their first approach was deciding a cap on the quantity of lead-acid batteries that are produced, and their second approach, which is targeted towards the scrap metal site in Accra, Ghana, as well as improving the health outcomes for community members, is soliciting funding for manufacturers to provide countries most impacted from e-waste and used lead-acid battery recycling with the resources required to properly recycle. And these resources include PPE, hands-on training, and machinery to help clean up waste. 2 challenges in regards to executing these approaches are regulating the manufacture of lead-acid batteries and ensuring safer alternatives are in place, and secondly, ensuring resources are used directly for its purpose. The following are related sustainable development goals in regards to the issue of used lead-acid battery recycling. The lessons we learned throughout this presentation are that in order to achieve a better and more sustainable future for all, we must collaborate through partnerships and discussions, as well as propose strategies to deliver on these goals. Here are the references I used for this presentation and for my background research on the topic. I'd like to extend a special thank you to the 3 professionals who actively participated in this discussion. Thank you for watching.